So I'm Francisco Riveros, Senior Cloud Architect by T-Systems, and today we are going to explore cloud-native patterns, but not in the usual techie way, jargon-filled way. Instead, we are going to look into how these patterns could solve everyday problems you maybe want to or might even face today. So here's the game plan. First, I'm going to present you why I choose this topic or what I have the rationale to have this topic. And then I will take a look on some common everyday struggles, and you will match them with cloud-native patterns. So this is an interactive session, I'm going to request your help here. Okay, so as I said, you may be wondering why I choose this topic. Why, right? So when I was brainstorming ideas for this conference, I said, okay, how I can do this, what I can do this, and I asked also my friend AI, and of course he said some ideas, but yeah, the real inspiration comes when I was in the university. I must admit, feels like ages ago. We had some courses of software engineering and software architectures, and we have to learn a lot of design patterns. And my friends and I, we had to kind of ideate ideas how to kind of really nerdy way, but how to relate these software design patterns with real life scenarios, so apply to real life, in order to get into your mind, right? So it sounds geeky, it maybe sounds geeky, but it's a lot of fun. I mean, you will see. So why not, right? So I want to give you today the chance to interact with me and to have fun, and maybe learn something new if you haven't. But yeah, so are you ready for this? Yeah? Yeah, perfect. So, well, the first attempt when I was also in the university was when I tried to match software with a traditional method, what's called trees. You know, how many of you know what is trees about? Raise hand. No? Perfect. I mean, TRIZ is really an acronym in Russian, which means Theory of Inventive Problem Solving, right? It was developed by a Soviet engineer who analyzed thousands of patents and inventions to identify common problems and patterns and principles of innovation, right? So usually this method, TRIZ, you could take a look after in Google, right? These are used by big companies like, I don't know, Coca-Cola or whatever. I mean, big companies to ideate, to have ideation solutions. And you could do the same tools and techniques for software development, and you could see like them in different perspectives. So, I mean, that was a thing that I did like 2008 or so. But with TRIZ, you can improve software development in some way with using the tools and techniques on that. But if you want to learn more about this, please contact me after this presentation. But let's kick off with a quick refresher. How many of you knows what cloud-native patterns is? Great. So, I mean, these are really true and tried solutions that help us design systems that are scalable, resilient, efficient, and portable, right? They are like IKEA instructions to build modern applications, right? But with fewer missing parts, of course. So let's dive with the real fun, right? Applying these patterns to the real life scenarios. I'm going to present you some scenarios, some problems, and then please take your Slido accounts, because I will require your help here. And as a surprise, this session will give you the chance, if you participate, to win this book, The Kubernetes Operator Framework by Michael Damm, with Pack, right? So take care. So you could win this book. So first scenario. imagine that you are in a crowded cafeteria. There is only one cashier, and there is a line that is getting longer and longer, and the people is getting impatient. And someone is about to lose the control and lose the cool. How do you handle this situation? What do you think the cloud-native pattern could solve this issue? You have some idea? Perfect. Yeah, exactly. I mean, we had it also in these 2 days in a long queue for the lunch, right? So this is the Slido. First option, offer everyone the same meal. It will be like some kind of caching, right? Because you offer the same meal for everyone, they can grab and go, and then you don't have to really need a cashier to do complex iterations, right? Or option B, distribute the crowd across multiple cashiers, which is kind of pattern distributed load pattern in cloud native application. Yeah, it could be. That everyone gets the food faster and the cashier as well. Maybe throw free food. Yeah, of course, it might be chaotic, but it will at least will clear the line. And the last one, I think, is one of the best. I mean, if you know it, hire an extremely fast cashier, like the ones from Lidl or Aldi. I don't know if you have the experience of that, but they are extremely fast. So what could we wrong with that? Okay, so have you chosen? Yes? Oh, well, you need 1 minute? Good ones. I mean, try to relate the good one. I mean, the funny one will be like the last one, of course, I admit. But
what if the funny one is the good one?
Maybe the funny one is the good one, exactly. So, 1 minute, I will drink a sip of water, and then we see the solution. So, yes, exactly. Distribute the crowd across multiple cashiers, distributed load. Yeah, I mean, these are really great thoughts, right? The solution here is similar to what is the load balancing pattern in the cloud-native application, right? At first sight, you might be thinking about hiring and putting a lot of cashiers because this will solve the problem, but it's not more the most efficient solution, right? What if we take a step further and we just the load balancer does, which distributes the traffic randomly but directs to the appropriate server, like using a person who is saying, okay, this is the next cashier available, and and then going there for like the load balancer does when you have a request, and then you say next server, right? So in this way, the crowd is spread out, and everyone get the meal faster, right? Simple, highly effective. You could use the load balancing pattern for your crowded cafeteria. So here are some examples for AWS, some examples of architecture AWS using the load balancer pattern, and also by in Google Cloud where you use the load balancer. Next scenario. Your email is overflowing with emails, your inbox. The important messages are getting lost in the noise. You have been trying to organize them, but it's not enough. It's too much to manage manually. What do you think? What cloud native pattern could solve here? You have something? This is one of the options, yes. So let's see. Here, Slido again. First option. Wait until the end of the month and then read all the emails once. Yeah, batch processing. Yeah, why not? I mean, let's say efficiency is like, right? Set that an autoresponder and say, my inbox is down, please try it later. Circuit breaker. Create rules and filters to manage flow of emails. Yeah, could be a queue-based load leveling, just smoothing out traffic bursts, like keep your inbox under control, right? Or forward all the emails to your boss and see what happens. Could be like chaos engineering, right? So it's a bold strategy, but yeah, might work. So, did you vote? Perfect. Let's see. Exactly, yes. So forward your emails. Okay, who is too bold to do that? But yeah, exactly. The solution is here. Yeah, to spot on. Right? There is a need to create rules and filters. Is what you are doing, for example, in your email, to prioritize and manage emails systematically, so you have the important emails in your in your main inbox, right? So what in the cloud native pattern could be is the queue-based load leveling, what is called pattern. Yeah, in the cloud native app, this will means like using a message queue to handle traffic bursts. Of course, the application logic that you see here on the function control and the function app is needs to control the rate of how the requests pass through to the data store. Otherwise, we will have the same problem. We will reintroduce the same problem in the backend, right? But then important emails will never miss it if you apply this pattern. Scenario 3. Imagine that you are planning a surprise party, but there is a catch. You have to coordinate with dozens of your friends without tipping of course, the birthday person, which is a surprise party. So how do you manage this secretive operation? What cloud native pattern could help here? Which one? So, yeah, of course. Well, here's the slide again. First option, send everyone a handwritten letter. Yeah, it could be like a monolithic architecture, slow and prone to delays. Second option, create a private group chat, like an event bus. Yeah, could be, right? Yeah. Coordinate through smoke signals. Yeah, it could be like point-to-point communication, but it's kind of inefficient, and you have to explain the fire in your backyard to your neighbors. And pretend that the party isn't happening and show up the house unannounced, chaos engineering, and see what happens, and hire a secret agent to relay messages, mediator pattern, but what happens is the mediator is failing. So, let's see. Exactly, event bus creates private chats will be the solution, the real winner here, because it's just like an event-driven architecture, right? So by assigning tasks independently and coordinated through this central hub, you ensure that everyone gets or is in the same page, and without spilling the surprise, right? And it's a perfect way to manage a complex operation while you keep the birthday person in the dark, right? Below you see e-commerce systems that is implemented using an event-driven system. Events are generated by event producers and ingested and filtered by event router or brokers, and then fed out to event consumers, right? So this is an example. So, scenario 4. Imagine that you are in a long road trip, that you are driving through a remote area, and when suddenly your car starts to overheating. You are miles away of the nearest service station, and you need to do something. What do? I think we have touched that cloud native pattern before, but I think we need to get the idea. So this is another Slido. Slido sadly is only allows you 3 free. So this is another way to get your name. So if you join here, it would be great. Then your name after the end of the session will be, and then you will win. Sorry, the book. So I will keep some time to. Please refer to your name then when you win it. Well, my name is there, but it was testing. If I win the book, yeah. Okay, are you ready? Yeah. Great. So let's do recap. We are in a long road trip. Our car is overheating. There is the need to do something. Which cloud native pattern could solve here? So let's see. This is the question. Which cloud-native pattern will help here? Off-server pattern, circuit breaker, proxy pattern, or singleton pattern? Well, I need something like a background music to do that. Let's see. Are you ready? Have you? Okay. Yeah? 1 minute? Perfect. So, yeah, exactly. So, the winner, circuit breaker. Exactly. So after that, after the end, you will see your name. But yes, exactly. Circuit breaker is a solution here. It's a great example where these pattern cuts could save the day. In a cloud-native or cloud architecture, a circuit breaker prevents cascading failures by detecting issues early and taking preemptive actions. Here you might think like the car temperature of your indicator and the warning light of your car is like your circuit breaker. When the car starts to overheating, then you pull over, right, to let it cool down, rather than the risk of the engine to completely be damaged, right? So this stripped the circuit to isolating the problem and giving you the chance to recover while before the things are getting worse, like you destroy your car. So in a cloud-native system, this may be familiar, so similar to temporarily stopping requests to failing service until it is stabilized, rather than continue push a request and then to have a complete system failure, right? So this is something like a smart controller responses to avoid bigger issues. Finally, okay, this is the last scenario. So you are in a birthday party with a bunch of hyperactive kids. They are all over the place. One moment they are eating cake. One moment the other next are bouncing off the walls. So how do you do to keep them on these chaos under control? What could be the cloud-native pattern that could apply here? What do you think? Yeah, some ideas? Well, also you can see as Doctor Strange to making the kids disappear, but okay, we are talking about cloud-native patterns. Yeah, let's see, get ready. So the same, I think maybe you are there? Are you? Or it's not working? 54%? Okay. Okay. So, which is the pattern that could apply here? Sidecar pattern, gateway pattern, adapter pattern, or proxy pattern? What do you think? I mean, each of them, they have their own characteristics, and they could help with this chaotic party. Ah, really? Oh my God. So, slide demo. So, no, nothing. Not at all? Perfect, perfect. Woo. Demo gods, as they said. So, did you vote? So I think in this one we can see the winner. So 1 minute, 1 second, and yeah, maybe I will run it out. Yeah, so most of them, sidecar pattern, gateway pattern, adapter pattern, and proxy pattern. The answer is, of course, sidecar pattern. I will explain you how this will be an analogy. Yeah, Alex N. is there? Perfect. So after the presentation, I will give you the book. So thank you very much. So yeah, sidecar pattern. Why? Right. Sidecar pattern is handy because in cloud-native terms, you will attach sidecar services to handle specific tasks without changing the core application, right? Here you could assign sidecar adults to specifically watch over different type of bunch of group of kids, right? One handles games, one handle food, keep an eye on the food. It's all about delegating responsibility and to keep the things smoothly, right? Running smoothly. So if we talk about characteristic of the sidecar pattern, in the sense of this example, isolation sidecar adults are separated from the main application as the sidecar pattern, like the party. Are specialized functionality. I mean, each sidecar adult is responsible for a specific task or tasks, right? It's only for watch the kids playing or the food, right? Loosely coupling. I mean, sidecar adults can be added or removed. I can say, hey, can you take a look at now to the food or to the kids and gaming? I mean, I can add or remove like a sidecar pattern. And improved manageability. I mean, delegating responsibilities to sidecar adult could simplify your overall management of the whole party, right? Great, right? So, what we have learned today. So this is it was the last the last scenario, but cloud-native patterns are not just for apps, as you could see. There are tools for problem solving everywhere. I mean, from the cloud to the cafeteria. By understanding these kind of patterns, knowing them and when to apply them, you can design applications that are not only robust and scalable, but also adaptable to the real-world scenarios, right? Whether you are managing a busy server or a crowded cafeteria, the right pattern can make all the difference. So yeah, thank you very much for being such a fun, interactive audience. Remember, architecture is about to solve the problems, whether it's in the clouds, on the ground, or anywhere in between. Thank you very much.
Thank you for a fun presentation.
I hope.
We had one question,
nice.
and I had to accept it because I think it was interesting. Again, how many times a day do you think about design patterns? Is this your Roman Empire? Are you going to?
Yes, exactly. I mean, I wake up and then I say, which design pattern I will apply here? I mean, usually I do for my son, a circuit breaker. I will circuit here when it's too much. No, it's really fun. I hope that you have enjoyed it, and yes, kind of the last of the sessions is more or less light, and I hope that you have maybe something had something insightful to get.
Everything, going to the toilet, design pattern.
Exactly. I mean, you can apply. You can do that exercise on your own, and for example, in your teams, just to, and when you want to apply something and you want to remember, something is a good option to do these analogies. Yeah.
Awesome. Thank you again.
Thank you very much.
Big round of applause for a fun talk right at the end.